Let's see if you remember them. First one, what do we do with exponents? Add them, right. When you multiply, you add exponents, yes. These are all pretty basic things that you should know already because we've been over it. When you have division, you subtract. Now, how do we know where to put our answer if we're subtracting on a fraction? Where the larger, good, because that's where they're going to be left over, isn't it? Good job. The other one, called a power to a power. You remember what we did with that one? Thank you. Danny, could you say multiply? Yeah. You multiply. You multiply exponents. And there could be more than one letter in here, more than one variable. So you multiply all the exponents by this outside variable. Then we have the most famous one that most people never remember. Thank you. Our last class said 0. You always say 0 because you see that 0. No, it's 1. Anything to the 0 power is 1. I can prove it to you with the division property. If you have x to the second over x to the second, doesn't that equal 1 right there? Since it's the same thing over itself. And then if we use this division property, what do we get? Isn't 2 minus 2 going to be x to the 0? There you go. So see, anything to the 0 power is going to equal 1. All right. That's how you prove things in college when you take classes theory. You use definitions and prove them. It'd be good for you to do some of that. What about a negative exponent? And I did this to help you. Thank you. Wherever it is, if it's negative, you make it positive by moving it to the other place. Yeah, move it to the other place in the fraction. So if it's negative exponent on top, to make it positive, you move it to the bottom. Remember, I also gave you this one so you'd realize that if it's negative on bottom, how do we make it positive? Move it to the top. Now, do you remember all those little exponent properties? All right, do number 1. Let's see. Just simplify it. Simplify number 1 for bonus. I'm going to erase these here, so if you want them written down, you need to get them down. The reason we're reviewing this, the next section in Chapter 7 is rational exponents, which means we're going to have to apply these properties to exponents that are fractions. And that's why we needed to review it. Something I taught you that I like to do, or have students do so you can keep things straight. Everything right now, if we wrote it as a fraction, would be over 1. Do you remember me doing that? I told you to draw your fraction line. Then if you have negative exponents, you know where to move them, don't you? So, how many got an answer already? What's the answer to this one? Grab one of those in. He says 4y over x cubed. How many got that? That is correct. Because, what's y to the 0? That's just 1. Where does the x to the third have to move to become positive? X to the negative third? To the bottom. He stays on top. We're done. Do number 2. By the way, give yourself a bonus point if you got that right. I'm erasing these laws. I've got to have room here, so if you don't have them, you can get them from somebody else or ask me again here later. Kind of like to do a couple of each type. You're going to have plenty of time to work on this. Should be able to get it done by tomorrow. Now there's different approaches. As long as you use your exponential properties correctly, you can start the problem different ways. I know the first thing I would do to make it easy, I would do this property. I would do this first. Add exponents on the ones that I can combine. Don't I have 3 b's up there? And what's everything connected by? Multiplication. So can I add all the exponents of the b's and get it down to a single b? What else can I multiply together up there? 3 and 4. 3 times 4 is 12, isn't it? The 8 to the third is not affected. We don't have any other 8 to the thirds, do we? Now I'm just doing one thing here. I'm not going to try to write the answer. So when I add all the exponents of the b's, what do I get? Yeah, -5, because isn't there a 1 on the b? So we have -3 plus -2, or excuse me, -2 plus -4 is -6 plus 1. Now if you stopped here, I'd take points off. Because what do the directions say? Positive. Well, the directions say write your answer with only positive exponents. So yes, now we would move him to the bottom and we would be finished. How many got that right? Give yourself a bonus point. Do we need another one of these? Or are you ready to go on? You want another one? Do number 3. Try number 3 then. Oh, this one's not too bad, is it? Did everybody do what I did on the first one? Did you add exponents on the variables first? So if we do that, we have 4. What's going to be x to the what? -6. Y to the what? Yeah. Now that simplifies it nicely. Pretty easy to see. What's the y to the 0 become? Yep. So it's basically gone. So our final answer would be, how many had that as an answer? Give yourself a bonus point. Now I think let's move on to some more here that have different laws. I think the next one changes on number 4, doesn't it? Yeah, 6 is different also, but let's see what 4 looks like here. Go ahead and do 4. This one we add the power to a power property. If you just did one step at a time, how many had this first? That's if you just did one step. Like the y to the 0 becomes 1, doesn't it? And again, everything's connected by multiplication. This is your power to a power, which means we multiply exponents. Now you have a choice here. You could go ahead and add the x's exponents. If I did that, 2 times 1 is 2, and then x to the negative 11, right? When you add exponents. Now, how many had 2 over x to the 11th for this one? Good job. I feel like I did a good job teaching this. You're remembering. Give yourself a bonus point. Now let's go down to number 6. Does that look pretty hard? Let's see here. 5 is similar to 4. We don't need to do it. Yeah, do number 6. This gets a little tricky if you forget about that the n has its own exponent of 1. And so does this 2 over here. Everything has an exponent. Everything has its own exponent. We just don't write the 1s, do we? So you don't want to forget about those. The key to this is working inside out. So this would be 2m to the 4th times, let's just do this power to a power. So that would be n to the 4th, excuse me, negative 4, m to the negative 8, wouldn't it? How many had that okay on that? And then all of this is still raised to the 2nd. Now what are we supposed to do with that squared outside? Multiply times every what? Exponent on the inside. So you would have 2 squared m to the 8th, n to the negative 8, m to the negative 16th. What 2 could we combine? I'm going to go ahead and make this 4. Then you'd have m to the negative 8, n to the negative 8, wouldn't you? when you add 16 and negative 8 on the m's, or negative 16 and positive 8. And then one more step, and what would we have for our final answer? Exactly. Now I did every step one thing at a time. If you're not comfortable with going fast, which you shouldn't if you don't feel it really well, like if you don't understand it really well, I would go through everything like that to keep it in order. Give yourself 2 on that one if you got that right. How many got that right again? Good. All right. Let's see what else we have. I don't think we need to work all these. Now we're going to do some fraction ones. Let's go ahead and we can do 7. That one's an easy one. That's just basic algebra 1 there. Simplify that fraction. Papers are over there. Not that one. There you go. And this one's a good one to review because of what happens on top. Gonna sneeze? Look at the light. That's what I always do. Or look at the sun. Makes me sneeze. What's left on top on this one? Yeah, doesn't everything cancel on top? And you don't leave it blank. In fact, anytime you do this, for example, cancel an x, you should be putting 1s there. That leaves me an x to the 3rd on the bottom, doesn't it, when I subtract exponents? We don't write it usually when you cancel, but that's really what you're making. You're making a 1. And then you have y to the 3rd cancels 3 of the y's on the bottom. 4 minus 3 leaves me 1. Is that our answer? Okay. 1 over 3x to the 3rd y. How many got that right? Give yourself a bonus point. Are we okay with fractions? Let's do one with some negative exponents. Let's do number 8. That one's pretty easy though. That'll be pretty quick. Now let's just go ahead and jump to number 10. Let's jump to number 10. Because we're still doing a fraction here, but we're throwing other things in here. This has almost every exponent property in it. I wouldn't even mess with the couple of things up there. I'd mark them out immediately. What am I talking about? What's 2 things up there I can get rid of immediately? Aren't these both 1s? Isn't this a 1 and this a 1? Yeah. 1 times anything doesn't change it. Now here's where you have to be careful. 2 and y have their own exponents. So we'd have x times 2 squared y squared x to the 6th. How many did this okay so far? All right, what's our final answer? What's on top? 1. Yeah, because he's not going to stay up here, is he? What happens when we move him down? Comes positive down here, doesn't it? I move the y to the negative fourth down here, becomes positive. Now another way you could do that is subtract exponents, but I don't want to get into that. I could have taken 2 minus a negative 4 makes it a positive 6. Isn't that what we're going to get when we add the exponents here? So you could have used the subtraction for division on the exponents and get the same thing. So what do we have? We have 4 x to the 7th, because this has a 1 here. And what's left? Y to the 6th. How many got that? Okay, let's just try one more and we'll be done. Give yourself a bonus point and do number 12. Or something up there makes that one simplify pretty quick. How many of you in here are taking some AP tests tomorrow and Friday? Is tomorrow and Friday? AP? That's biology, I think, ECA, isn't it? That's for freshmen, though, isn't it? Do what? It's later. I know, though, from this point on, it seems like, though, we got something every week. It really messes up the schedule. But yet, they still expect us, though, to get everything done. All right, what happens to this right off the bat? Isn't that just 1? Yeah, anything to the 0 power, it doesn't matter what's in the parentheses. Parentheses to the 0 power, so that's just a 1 there. So you can mark that out immediately and put a 1. You don't even need to multiply your exponents because each one of them is going to become 0 anyway, isn't it? All right, over here, 2 has its own exponent and x. So now let's multiply those by negative 1. You'd have 2 to the negative 1, x to the negative 1, y to the positive 2, wouldn't you? Let's make this a little bit better here. All right, and that's all over x squared y to the 4th. So what's on top? No. Not in your final answer, y squared won't be. Now in the next step it will be if you're just doing like if you're just taking care of the x's first and moving this down. The 2 comes down here, doesn't it? It's got a negative 1 as an exponent. What happens to the x? And we already got an x squared, so what's it become? X cubed. You know you can use your subtraction rule for division. What is 2 minus a negative 1? Plus a positive 1. So 2 plus 1 is 3. Or if you just move it down, it would be x to the 1st times x to the 2nd, which is the same thing. All right, so we've taken care of this. Now what happens with the y's? Yeah, so if there's not anything left on top, you have to put a 1. Are we finished? How many got that answer? Bonus point and I'm finished. Your assignment, should you decide to, no, this is not Mission Impossible, is it? You have to do all of them on, I think I gave you 20, didn't I? But I also told my other class you had to finish the examples. You have plenty of time to do it. In fact, some of you in here could probably finish all of it before you leave today. Then we're going to start on rational exponents.